Okay, so we are on our last example, number 3, using the quotient rule. And basically what we were saying is if we have to take the quotient rule, we have to, it will be necessary if we see a fraction with a variable in the numerator and a variable in the denominator, where my denominator is not a monomial that I can simplify. So it's not. We have to use the quotient rule here. So the first thing I want to do is rewrite f of x. F of x is x, the square root of x is x to the 1/2 over x cubed plus 2. So I'm going to call this, my first f of x is x to the 1/2, and the derivative of the first is 1/2 x to the negative 1/2. And then g of x is x cubed plus 2, and g prime of x is 3x squared. Okay, so now to take the derivative. It's the derivative of the first times the second minus the derivative of the second times the first all over the second squared. Okay, so here we go. F prime of x is equal to, I'm going to do big brackets, and the derivative of the first is 1/2 x to the negative 1/2 times the second, which is x cubed plus 2, and that takes care of my first bracket, minus, now my second one goes, derivative of the second, which is 3x squared times the first, x to the 1/2, all over the second, which is x cubed plus 2, and that whole thing squared. Okay, so now we're going to try to clean up as much as possible. This is 1/2 x to the negative 1/2. I can distribute that inside here because this is raised to a power of 1. If this binomial was raised to any other power, I'd have to leave it like that. So then I get f prime of x is equal to 1/2 x to the 1/2 times x to the third. You know you add those exponents, so you get x to the 2.5, which is 5/2. So I get 1/2 x to the 5/2 for that first one, plus 1/2 x to the, and now we go ahead and multiply that. 1/2 times 2 is just 1, so I get x to the negative 1/2 in my first parentheses, minus, and this is just the monomial, 3x squared times x to the 1/2. Well, here you add those exponents, so I get 2.5 again, and that's going to be 3x, and 2.5 is the same thing as 5/2. So that's in my second, all over the denominator squared. And last but not least, we have to combine the numerator. Here there's nothing to distribute, so I could get rid of this. And this monomial just turns negative. So I have a negative 3x to the 5/2. Well, I can combine 1/2 and a negative 3. I'm going to get, again, negative 2.5, or negative 5/2 x to the 5/2 plus x to the negative 1/2 all over x cubed plus 2 squared. All right, so now it's time to clean this up, and this gets a little bit tricky because of the fractions. And we look at this and I go, this is the same thing as f prime of x is equal to negative 5/2 x to the 5/2 plus 1 over x to the 1/2 over x cubed plus 2 squared. Because this is your first time doing this, I'd be fine with you leaving your answer here. But if you notice, this is a complex fraction. So I'm just going to clean it up as you would eventually be required to do. And in this complex fraction, it's f prime of x is equal to negative 5 halves x to the 5 halves plus 1 over x. I'm just rewriting what I have, and then I'm going to see what my common denominator is. This has a denominator of 1, so my least common denominator is 2x to the 1 half. And I just multiply that to every single term, 2x to the 1 half, 2x to the 1 half, 2x to the 1 half. So when I do that, this just becomes, the 2's cancel, and I have in the numerator, f prime of x is equal to negative 5, and then we add those exponents when I'm multiplying. So that just becomes 6 halves, x to the 6 halves, which x to the 6 halves is going to reduce to 3, plus this is just going to be 2, over 2x to the 1 half, x cubed plus 2 squared. So last but not least, what looks super complicated that isn't so bad becomes this. All over 6 divided by 2 is the 3, and this is 2 square root of x cubed plus 2 squared, and that would be your final answer. All right, so your homework, just look at the worksheet. You have a couple of problems to try there, and then we will be doing an extra help session to answer any questions. Thank you.